do we need to use only Windows 10, or like the Windows 7 or Windows 8 would do? And also, like, what size of random access memory we have to use?
Okay. So yeah, this software is, in fact, with the versions, it is a bit demanding where you need to have Windows 10. It doesn't work on Windows 7. But one thing is that this is one of the few CAD softwares which also works on a Mac. So if you have a Mac, you can use this. In terms of requirements, it doesn't take a lot. So I was able to comfortably run it on an i5 laptop with integrated graphics and 8 gigabytes of RAM. I think it could potentially run, although slowly, on a laptop with slightly lower specs. But if you're looking at something like an i3 with 4 GB of RAM, I think that would be difficult. But one thing that helps a lot is having a graphics card, which, yeah.
Thank you. And then Diaz asks, how long have you been using Autodesk 360?
So I've been using it for just slightly over 2 years now.
Okay. Anil asks, do you think that there will be any other challenges, competitions after quarantine, after lockdown?
Yeah, I think definitely. So, right now, a lot of places have actually adapted, especially with robotics, they've adapted very well to the quarantine. So, in fact, first, they have another challenge called the First Global Challenge, which is sort of like an Olympics where each country has one team. And they've actually moved that entirely online. So, they have a completely online competition for that. But yeah, I think, a lot of things, it's just that physical experience helps a lot. So like when you're building a robot, it's a very different experience when you actually get to work with those tools, when you're drilling those holes yourself. So yeah, I think this is something that is definitely not going away after quarantine. These contests will definitely be back and you will find a lot of these opportunities.
Yeah. As for the first global challenge, last year in Dubai, the team
Yeah.
Kazakhstan took third place in there. I mean, we got a bronze medal.
Yeah, that's really impressive.
Yeah, thank you. Okay, Yerasil asks, do you use this model to show a robot in engineering notebook? If yes, how do you render it?
Right. So this may not apply to all CAD softwares, but Fusion 360 is sort of like an all-in-one type thing, where you have a render workspace where you can have these sort of renders for the marketing of your robot and all, and you can also create technical drawings. So based on the robot, you can add like a drawing of the front view, side view, orthographic view, etc. Quite easily. So that's something which you can do if you need to.
Okay. Okay. Imanali asks, this program has just materials and details for FRC only, or we can use materials of other robots or projects?
So this Fusion 360 has no affiliation to FRC. It just has a lot of different materials available, and a lot of them tend to be useful with FRC. One thing to note is that there is a CAD software called Onshape, which has affiliations with FRC. So, for instance, if you might find it really difficult to find parts online, something like Onshape has a library of every single FRC part. So that might be something worth considering.
Okay. Can you say about your rewards?
Yeah.
Or competitions?
So I think with this, it's sort of you sort of do it for the competition, you do it for the experience, where it's just you end up learning so much while building these, and it's very hard to quantify, but you can sort of get that intuition, which is something that is impossible to get from learning engineering in a textbook and all. So it's like right now I find it like second nature, but then I sort of realized that it isn't something that you just you can expect everyone to just know, but then you can see some structure and you can be like okay, wait, this is a better way to do it. It's that might be too complicated, or that might be great, or something like that. You can have that sort of understanding.
Okay. And previously you mentioned that there are lots of competitions, virtual competitions. If you could provide like 2 or 3 links to them, just to give an general background to our attendees?
Yeah, so I think one place where I've
I mean, where to look for, you know? I mean,
right.
how do we look at? How do we look?
So, yeah, so I think definitely your existing robotics competitions will have their online variants. That is something you can definitely check out. Additionally, it's really good to look at resources from CAD companies. So, for instance, I'm very involved in this thing called Autodesk Academy, which is sort of like a small forum page by Autodesk where they have a lot of these competitions. So, in fact, that's how I found out about the Stanford Autodesk Mass competition. And I think additionally, on top of that, this may not be like CAD specific, but there are a lot of online sites where you can basically collaborate on projects with people from all over the world. So I think like Helpful Engineering is one that I know of, but there are so many of them out there where you can basically use these skills in a project and you can just, work together with how many other people you want from all across the world. You may have never even met, but you're sort of brought together by these wanting to make a difference.
Thanks very much. And Emanuele again asks, does this program have physics? That is, I mean, it is like necessary to attach nails for the robot to stand.
So in that sense, it's not necessary to attach nails for the robot to stand. That's mostly something which you just do to be more clear with your design and have the holes correctly aligned and know, what screws you want to buy. But as for physics, in that sense, in another sense, it does have physics where you can perform simulations and all on your robot. But simulations are more for assessing the structural viability. So, it's saying like, okay, let's say under XY load, will it break? Or like, will it deform, etc. It's not so much about like, will it stay together?
Okay, cool. And then like how long did it take like to create the whole project, the whole robot with intake, with shooter, with the platform?
Yeah, so I mean, normally FRC robots tend to take a lot longer, but because we were under a time crunch, we finished this whole thing in a week. But it's also like planning is very important. So for instance, with this, we didn't necessarily have the best planning. We didn't end up doing a lot of work towards the beginning, and we ended up doing about the half of the work in one night. So it's just in that sense about what the situation demands. But yeah, I'd say something like this is about 1 week of healthy work.
So basically, you're saying that when you're enthusiastic about something, it is, I mean, you can work like days and nights.
Yeah. I think also a very important thing with this is that it's really easy to sort of just like come up with a bare bones robot. What makes this process sort of time consuming is sort of like how I tried to go through with my live design, is where you sort of try out something, you see it doesn't work, you see, okay, how can we improve this? What was the issue in it? Like running those simulations and all, testing out things and all, that whole iterative process.
Okay. How about CLEO parametrics? Like, you know about that kind of apps?
So I've heard about CLEO as a CAD software. However, I can't really comment on it because I haven't used it myself. But if you're referring to like parametric modeling as a technique, so yeah, this software also uses parametric modeling. However, there are also softwares which use like, I'm not sure about the word for it, but it's like even more parametric where everything is sort of like based on functions and all. So that is something which you'll have to see some other software for. But this is generally what's used by most engineers.
Okay. And like, do you need to know modeling to do this kind of details?
So in that sense, it's important to be familiar with your CAD software and understand how to use it. So I would say yes, but in that sense, you don't need to like, let's say, take a design course or something to start with this. It's a lot of it you just learn by doing.
And like, what kind of processor do you use for that robot? I guess he means for the FRC robot?
So the robot, so with FRC, in fact, they sort of give us the electricals. So that's one thing where we can't really change them. We have to use those just for safety reasons. Other than that, processor, which is a RoboRio, we also use an Arduino for an Arduino and a Raspberry Pi for certain things. Teams may pick whichever one suits their purpose better.
Okay. And Diaz asks, like, from what age range, like, would you say is like more or less fine to use Fusion 360?
So I think honestly it really depends on person to person. I don't think there's like ever I don't think you can be like too young for it that you shouldn't try it. So like for instance, we have done like a CAD course with students in our school. So we did it from like grades 8 to 12. And the thing that we noticed is that the best students, like 9 out of 10 of them were from the 8th grade. So I really don't think it's like you're too young for it. You should definitely give it a go. You may find it difficult, you may want to try again when you're older, but it's I don't think you should ever let that stop you.
Okay. Like, have you built that robot? Have you like actually built that robot?
No, so we made it in quarantine, so we haven't gotten any opportunity to build it, but if we do have time, it might be something we want to build.
Yeah. And like, do you think, can you give like a roughly estimate numbers how much it would cost?
So I think I'm not really sure about this, but one thing to keep in mind is that all all existing FRC robots next season, that's not the case, but all existing FRC robots cost less than $5,000. And I think since this is a relatively simple robot, I would put it at around half that. So like the upper end of the estimate might be around $3,000, but hopefully less.
And then I guess the last question: what was your the most difficult project in your life?
So I think in that sense, I'm sort of like going from project to project. I think it generally the difficulty of a project depends on how aware you are of the skills required to do it. So for instance, like once I'd embarked on a project to create a working laptop using a Raspberry Pi, and all I knew about electronics was just V equals IR. So in that sense, that was something that was really difficult, but I think the learning from that was great. In terms of technically demanding, just like on an absolute scale, I would say probably the face mask that I made would have been the most difficult, just because you have a lot of variables to deal with, and it is sort of complex in that sense. But yeah, it's again, I have to say it's all very relative, and it's also about how much learning you can get through these projects.